Okay, very good. So we're going to talk about our fermentation too, which is, look at your slides. You can look at your slides. We're going to talk about sauerkraut, oliver, pickles, and vinegar. Okay, so we're going to talk about each of these one by one. So first of all, we're going to talk about sauerkraut. Okay, for this one, lots of you, if you buy a bottle of sauerkraut, lots of you will say, it looks like a salty, shredded lettuce. Yes, it's true, because it's shredded lettuce, immersed into the salt solution, and then they ferment it. So the taste looks like that. So we want to talk about what it is. Okay, first of all, there is about a little bit of history of sauerkraut. This one created about more than 2,000 years. Now, why would they try to do that? At that time, those businessmen from Dutch or from some other Spain, from European countries, they are trying to do the business to North America. Let's say America, Canada, all those places. And what they have to do is like long ocean traveling. Okay, it's not like today you from Pittsburgh airport go to Spain, Madrid, only like 6 hours. All the time taking 1 to 3 months. Okay, now what they need some vegetables, foods to have a very longer shelf life. Okay, they want those type of foods. What they need to do? Of course, fermented product is a choice. And then why they choose sauerkraut as a good resource? Because it has a higher amount of vitamin C. Now, what's the level it is? It is actually pretty high. Okay, it is somewhere between 10 to 30 milligram per 100 gram. It is actually pretty high. So it's a good resource for vitamin C. And you know the people, if they do a long-term ocean traveling, they do not have a good resource. They will have a bleeding of the teeth, which is related to anemia. Is that right? So that is why people find the vitamin C. So at that moment, the sauerkraut is a good resource for vitamin C. So that's a little bit of history, why it is being generated. So then we're going to talk about how they create, how we really process it. So you have those letters, okay? Those letters like this. Now, of course, those leafy, you're going to take it out. Any damage the leafy. And then you have something left. First of all, you have to shred it. Shred it into those small pieces. Okay, so you shred it. Okay, once you have those small shredded pieces, you're going to put it into a jar. Now, of course, sometimes they use a wood barrier or those small ones. You put these shredded leafies there, and you have to cover it completely immersed. And then you're going to add salt solution. So first of all, we want to mention this top, you have to be covered. Why? We don't want any of them to expose to the air because it's a fermentation process. So this has to be avoided. Aerobic environment. Okay? Then we need to add a salt solution. Now what's the function for the salt solution? Number one, this salt solution is 2 to 2.5%. The function number one is to extract sugar out of skin used for fermentation. This is the first function. The second, you know all these leaves, they more or less have some background bacteria. So we're going to have to kill them. Kill background. We can say unwanted bacteria. Now most of these bacteria will be susceptible to 2 to 2.5% of salt. So we call those are non-halophiles. Then which one we need? Lactobacillus or lactic acid bacteria we wanted. Okay? So LABS we needed. What are they usually? Lactobacillus. Leuconasdac. What the other one? Pediococcus. Those are the three major lactobacillus during the fermentation. Now, there is a true resource for these lactic acid bacteria. That could be normally exist on the surface, or you add it. Now, most of the time for these sauerkraut, we actually do not really add it. It's naturally existing on the surface. Okay? So then they're going to go through a fermentation process. This fermentation took about 6 months per year. And at the end product, the pH is lower, 3.4 to 3.6. Acidic percent is about 1.6 to 1.8%. And because the background unwanted bacteria has been killed, lactobacillus go in there to generate lactic acid, going through hormone fermentation. So lots of the time, it will be also become acid resistant. Lactobacillus or lactic acid bacteria. Okay? Now, another thing we also want to mention very important. This salt here also will have an impact for the texture of these leaves. What they are really impact is firmness. We don't want to be them too soft, and we don't want them to be too firm because its chewiness will be impacted. So the salt concentration is going to affect it. So what's the curve looks like? This is a salt concentration. This is a, let's say the firmness. And basically the curve is like this. You can say started at 0.7%, it is very soft. If it's higher to 3.4%, also very soft. At the middle of this range, 2.1 to 2.5%, this will become firm or medium firm. Okay, kind of like a curve. There's a curve right in the middle. This is about 2.5%. And you can see this the range of the salt is very narrow. So which means the salt concentration is actually very sensitive and very important for the firmness of these leaves. And you guys can do it at home. Buy some of the shredded leathers, cut it, put in a salt solution. And some of them even put some citric acid there later on to adjust it. It's become a sauerkraut. And we actually did this in our food and microbiology lab. You know. Now, this fermented temperature, usually 20 to 24 degrees Celsius, but took about 6 months. And leuconostic, this guy usually can grow as low as 7 degrees Celsius. Okay, we have a slide talk about that. But fermentation, usually they took at room temperature. And we also, when we finish this, we will do a batch. The batch we are taking about 6 months to complete it. And at the end of the day, the leuconostoc will actually be dominant. Okay. So that's a sauerkraut. The second one is a pickle. So we want to talk about a little bit. Right, sauerkraut we finished, we're going to talk about pickle. Basically, the pickle and the sauerkraut, there are some principles are the same, but there is something which is different. So we want to talk about number 2 is pickles. So what is a pickle? If you buy a bottle, there is a lot of food chemistry we can talk. Usually it is canned. Okay, you see those cucumbers. These sliced cucumber, not one big piece, or some smaller one. Those are sliced. But that's a very typical pickle. You can use in other things. Usually we use sliced cucumber, cut in the middle. We also going to add a salt solution. Okay, this salt solution will be higher, somewhere between 5 to 20% salt. This will be higher, not like 2%. You know why? Because it's a whole pickle. That is shredded a small piece. It's different. The area is different. And usually, typically, we keep the salt concentration somewhere around 8 to 12%. So what the industry they do, they dissolve 1 pound of salt into 15 gallons of water, and then they do refresh every 5 weeks. And you can do a calculation if you want to do. This is for 150 gram, 15 gallon, 15 multiplied by 6, 7, 8 ml, and you divide it by the 30. How about that? Approximately 0.08%. So that equals 8%. And you can do it each. It's very simple calculation. Okay, 1 gallon equals 3,670 milliliter, which is 3.67 liter. So that's what the industry they do. Now, what's the function of those salt solution? Very similar to here. Number 1, extract sugar for fermentation. That's the same thing. Number 2, you're going to inhibit background bacteria. Number 3, promote lactobacillus, lactic acid bacterial group to grow. That is also encoding lactobacillus, leuconostic, and pediococcus. Now, these type of lactobacillus, sometimes they also generate some of the chemical can beneficial the products and killing some of the pathogens, like pediococcus, they can generate sometimes. Okay? So that is the salt, the contribution of the salt. Now, there is a little bit of difference between here. This is usually fermented at 30 degrees Celsius at about 2 to 6 weeks. And this pH around 3.5, a little bit higher, and acid also around 1.2 to 1.5%. Okay, a little bit higher than that. Sorry, this is not a percent. It's just a percent, not a percent. Now, what are going to be the final products looks like? This is something we want to talk about. Everybody knows what the final products looks like. A little bit of brownish, a little bit of yellow, if you remember. And I did this thing all for the micro lab. I said, that's good. It becomes yellow and brownish. Now the question is why? Okay? So, there is three things happen after fermentation. Number one, this is the color changes from white to brownish yellow. Number two, this is a slightly translucent, not really transparent. Number three, these usually precipitate at the bottom. So precipitation, that means higher gravity. Now in the food chemistry class, we're going to talk about why this will become brownish and yellow. Why? Do you still remember? I tell you, you will remember. Look at your slides. If you look at your slides in 15, you will see looks like purplish, yellow. Then what's happened there? Why it originally turns green? Why everything is green? Because chlorophyll. What it looks like? What's the structure? Very basic. Okay, we don't want to go too complicated. Nitrogen and the magnesium in the center. If you go look at when we talk about the color, chlorophyll is very sensitive to acid, not sensitive for alkaline environments. And we're going to take it out. This magnesium will be gone. And then what's going to happen? If the magnesium comes out, the phytol comes out, become a final product, which is called 5-15. And this is brownish yellow. Okay, so that's why I always ask the students a question. When you see a pickle, why at the end of the day is brownish yellow? Because very easily to say, is this acid reacted into the chlorophyll? Take out of this magnesium in the center. The chlorophyll kind of like burned down. Because it's very sensitive to the acid. So where is this acid comes from? Comes from fermentation. Because it's a homo fermentation, so it becomes lactic acid. It's accumulated there. So magnesium is gone, the phytol is gone, become 5-15. That is brownish color. Okay? Well, that's a key for the pickles. Okay. Now we're going to talk about is olive. There is a slightly difference. Well, basically you still use salts, you kill bacteria, extract sugar, all those other things. But what's the difference? There is a major difference between compared to this to the others. Okay, this is the olive. I'm not sure you ever eat it. I don't like the taste of very good, but very much. You can go any of those breakfast place like eating pork. Get some salads, put some of olive. It's a little bit bitter. The first few. Why? Because they covered on the surface is a chemical called oleoropyene. This is pronounced as oleuropein, which is coming from olive tree. This is a phenolic compounds which have a bitter taste on olive skin. And the function of this guy is for antioxidant, but more important is protection for itself. However, this one we have to take it out. So how we take it out? We're gonna be pre-treated with 2 to 5% sodium hydroxide. And this process, call it LYE, line process. You must do this first, otherwise it's going to become very bitter. So you have to do that. Okay. Once you pre-treat it with this, we have to remove this. So you have to pre-remove. Then you're going to be immersed into 2 to 5% brine salt solution. Okay? How many days they're going to take in? Very similar is to pickles at 24 degrees Celsius, 2 to 3 months, a little bit longer. The dominant bacteria Leuconostoc and the Lactobacillus plantar. Now, for black olive, our slides tells you it's going to be increasing the brine solution a little bit higher to 5 to 7%. And you also have to be washed, remove the lye, and will be fermented 2 to 6 weeks, a little bit short, at 2 to 5% of the brine solution. Now, at the end of the day, it will turn black. Now, why it will turn black? Our slides tells you because polyphenols oxidized and turns black. Okay? So, if we wanted to do a conclusion, all of these three products, sauerkraut, pickles, and olives, there is a basic thing there, which is we need input into a salt solution to extract the sugar, inhibit background bacteria to grow, promote lactobacillus. Most of them is on the surface. you also could add it. And then it goes through the fermentation process, somewhere between 2 to 7 weeks to like 6 months. It depends. And for the oligar, we have to do some pre-testing, or pre-treated using lime process, because the allura pan has to be removed. Otherwise, it's going to become very, very bitter. Now, at the end of the day, it turns black because polyphenols oxidize, becomes black. Okay, so there is a food chemistry and also a food microbiology knowledge behind that. Next, we're gonna spending a lot of time talk about the vinegar production, and this is very important. I think we should know as graduate students. You graduated from a food science program. You should be familiar with the vinegar, how we get it. Although we're using them often the time when we prepare foods even at home, so we want to talk about the vinegar. Okay? We're spending the next section of the class to talk about vinegar. So we want to talk about vinegar. Okay, vinegar. If we want to say it's very simple, what is that? This is, we want to say, is secondary fermentation of wine or wine products. So this is saying a very layman, using very layman language to say it. If you want to try, you can try. You can buy a beer. Beer may not be a good choice. You can buy an apple cider, apple jack, or white wine, red wine. You're going to open that cap. Let the oxygen come in, expose at room temperature for about 1 to 3 months. Then if you can taste it, it will become acid. Because once it becomes a wine, it's secondary fermented with oxygen, with certain bacteria, it will generate acid, which is citric acid, acetic acids. So very layman language, we say it's a secondary production of wine or wine products. If you have a wine products, you continue to ferment it, it will become a vinegar. So what are the really material to making a vinegar? Number one, you need to have a substrate. What are the substrate? Of course you need a wine. Sometimes it's the others, wheat or wheat.